One thing to know about absolute value equations and solving them is that you will be splitting the equation actually into two equations. So let's go ahead and start with our example. Don't forget we have our absolute value bars, just like the ones I drew up there. And we have the absolute value of 3x plus 2 is equal to 8. Now we're going to be splitting it into the negative and positive versions of itself. So let's go ahead and answer this question first. Why? The equation will be true for both positive and negative values of the quantity inside the absolute value bars. And well, simply put, you may want to recall what it means whenever we're talking about absolute value. And I'd like to define that over here. The absolute value measures the distance from zero. So remember, if I were to ask you for the absolute value of -3, I wouldn't say that it is -3 units away from zero. I would actually use the positive version to say it is +3 units away from zero. Now, whenever you're solving an equation, you have to take into account the negative version as well as the positive version. So let's go ahead and get started on the easy one. How about let's start with the positive? Now, the positive version, you literally write whatever you had, just drop those absolute value bars. So I have 3x plus 2 is equal to 8. That one's really easy to solve. We would first remove the constant of 2 by using the inverse operation and subtracting 2 to eliminate it from the left side, leaving us with 3x is equal to 6. Now, we do have to remove our coefficient that is attached to my variable using multiplication. So the inverse operation would be division of that coefficient, 3. And that would leave me with, since 3 over 3 reduces to 1, just x equal 2. Now let's go ahead and do the same steps, more or less, but for the negative version. Now you'll notice that I went ahead and wrote the exact same equation minus the absolute values. Now let's go ahead and apply this negative version of itself by simply adding a negative to the front side of the entire expression. So I also need parentheses. Now remember that this negative is technically a -1. And what I would want to do is go ahead and distribute that negative. Or actually, I don't want that -1 at all. I want to get rid of that distribution. Now, distribution simply means multiplication. So the inverse operation to multiplication is, duh, we already said that, division. Now, I want to go ahead and get rid of that negative right off the bat. So let's go ahead and do that by dividing by -1. Now, I was about to distribute it, but honestly, I know how much you guys hate negatives anyway, so we can go ahead and get rid of it at the beginning. And that would make our life a lot easier anyway, because that leaves me with, after that reduces to 1, it'll leave me with 3x plus 2 is equal to -8. And now we can just solve like last time by removing the constant. Just as before, we're going to eliminate that positive 2 by using the inverse operation, giving me 3x is equal to -10. And of course, again, we would divide by 3, leaving me with 1x is equal to -10 thirds. Now, I'd like to show you a way to check your answer by using graphing. So let's go ahead and take a look at this. Before I write my final solution set, I would like to check the solutions by graphing the left side of the equation, 3x plus 2, the absolute value of it, and also the right side of the equation, just 8. So, I'd actually like to start with, how about the easy one? Graphing y is equal to 8. Because if you remember, back on our notes, I believe page 24, we talked about Hooyvaks. And whenever we have an equation that begins with y equals and just a number, that would be Hoy. That would create a horizontal line, of course with a zero slope, that crosses the y-axis at 0, 8. So let's go ahead and draw that 0, 8 right there, and of course a horizontal line for y is equal to 8. That was the easy one. Now, what we need to do is find where this line intersects with y is equal to the absolute value of 3x plus 2. Now, a quick side note. To recall from Algebra 2, the absolute value of this parent function, y is equal to the absolute value of x, we're going to have both the positive and negative versions of y is equal to x whenever we're taking the absolute value of it. Now, what that's going to create is the positive version that I sketched out lightly here, as well as the negative version, y is equal to negative x, right here. So just recall what the absolute value function looks like. It looks like a V shape. With that in mind, let's go ahead and begin graphing the absolute value of 3x plus 2. By creating the table, I'd like to use the following values: -4, -1, 0, 1, and 2. And I'd actually like to begin with the easiest one of 0. We'll be taking these inputs and replacing them right here for x and getting our y value. Now, don't forget, we also have to take into account that this is the absolute value, the distance from 0. So let's go ahead and take a look. That's the absolute value of 3 times 0 plus 2, which of course, you know that 3 times 0 is, well, just 0. And this is actually just the absolute value of 2, which of course equals positive 2. So let's go ahead and try the next one. 1. 3 times 1 plus 2. Well, of course, 3 times 1 is 3 plus 2. 3 plus 2 is, well, 5. So the absolute value of 5 is 5. So let's graph that one as well. 1 comma 5. Next easy one again, because it's positive, is 2. So let's go ahead and substitute that in. 3 times 2 plus 2. So 3 times 2 is 6 plus 2 is 7. So the absolute value of 7 is 7. So let's graph that. 2 comma. Oh, someone should have stopped me. This is the only thing I hate. I apologize. 6 plus 2 is actually 8. The absolute value of 8 is 8. Sorry, I noticed that I had a linear function happening here, and that's where I realized I had a mistake. There we go. Now, this isn't looking exactly right, so let's go ahead and get these other two values that I have that are a little bit more difficult. Let's substitute in -4. 3 times -4 is -12, plus 2 is -10. Now remember, if we're counting the distance is always positive, so it should be 10 is the absolute value of -10. So let's go ahead and plot -4 comma positive 10. Now let's do the same thing for -1, and last one that we need to do. 3 times -1 is -3, and then plus 2 is -1. The absolute value of -1 is positive 1. So let's go ahead and plot that on here. Now, if we were to connect these these two dots with a line, you'll notice that it has the exact same slope as what we had here, but it's negative version of it. So here I notice that I have a slope of up 3 to the right 1. So I should have down 3 to the right 1, again, down 3 to the right 1, and down 3 to the right 1. So let's connect that up. And if these two lines continued, we would have our complete absolute value, which I'll go ahead and draw it for y'all right here. So again, I'm looking for where they intersect and its x values. So my first x value that is spot on is at x is equal to 2. Although my next x value seems just a bit off. It actually looks like it's -1, 2, 3, and a third, which is our exact amount that we had here. So let's write our solution in a solution set, braces, and of course in ascending order. Don't forget to label this page 29 and flip it on over.